What's your take? AGI by 2027? Yes, no, maybe? Why?
I've had many meetings with folks who work at the very high end of things like this, both in academia and in the government research labs. And one of the main things is lack of. Recently, OpenAI has changed this for, we're presuming, funding reasons, that AGI is any system that can make $100 billion. They passed ARC AGI. And then everybody said, oh, whoa, 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 whoa. We didn't actually mean that when they passed that we've reached AGI. It just means
Look what happened between ChatGPT 2 to ChatGPT 4, where we moved from like a preschooler to smart high schooler like level of intelligence, and then extrapolate.
the hypothesis is if you as a human can guide the model to do superhuman things, that with the proper crutch, the proper framework, proper wrapper, it should be able to do it on its own. The one-liner take is we need to invest in moonshots.
Okay, so there we go. Journal Club, the first of many, hopefully. We're gonna tackle super interesting paper, but before that, yeah, let's see who we got today for us, Mr. Baughman. We went to school together, and obviously Matt was smarter and pursued the PhD path. So now at UFC, you wanna just jump in and share a tiny bit on the research area?
Yeah, no, so I'm a sixth-year PhD student graduating from University of Chicago. Obviously, you know this, but most of my research focuses around cost-aware computing, and doing kind of automation of all the terrible parts of distributed computing that people hate. We work with a lot of companies, a lot of research scientists who focus on domain areas. And really the idea of what I do is automating away the bad parts of compute so scientists can focus on being scientists, people in industry can focus on their product, on their customer base. They don't have to worry about machine configuration, optimizing their distributed systems workflows, or making good decisions. What we found is even the people who specialize in this, myself included, when you try to characterize or make assumptions about how workflows run on different types of computing resources, people are bad at it. And so why not allow a computer that is fast, is dynamic, and is directly plugged into that wider computing system take over all of that decision making, all the decision making overhead. So that way you don't have to worry about it. You don't have to hire some cloud architect to tell you what to do for many hundreds or thousands of dollars an hour. And I know it puts some people out of a job, but trust me, they'll still have a job.
Okay, we're starting with a hot take. I love
Oh, yeah.
this.
We're full of hot takes. All of this I should qualify as it's all my own opinions. In addition to my work in a PhD, though, I have the opportunity to work with a lot of projects at Argonne National Laboratory. I've worked with a lot of AI type projects. I was involved for a while with the Aurora GPT project, which is this idea of a trillion parameter model for science. And so that was kind of my formal introduction to this sort of state of the art LLM world, which makes me, I wouldn't say qualified to talk about this, but at least, I'm not completely making it up as I go along.
I
It's
would say
just a trained
you're
person pretending to be an AI person. I think that's the best way to characterize it.
yeah, no, I think you're definitely you were way more qualified to talk about this than most people talking about this. I might murder their name, but or his name, but Leopold Aschenberner, right, is an ex OpenAI super alignment division. He came up and I looked it up. He came out with this paper last year, I believe, right, in 24, the
Yep.
second part of 24. He's been pretty quiet on X. Basically, he got a shout out from Ivanka Trump, which is interesting to say the least. That was the last sort of like interaction he had on X. So that's another rabbit hole to go into in another time. But he came up with this sort of like seminal piece where, as you can see here, there's several parts. We're gonna cover today the key and the first and the key part, where basically he's making the argument AGI by 2027. Uh, if we jump straight from sort of like before, reverse our conversation and start with the bottom line. What's your take? AGI by 2027? Yes, no, maybe. Why?
I think there's several parts to that question that really require breaking down. The first, of course, is what everybody always constantly argues, and especially now OpenAI has been in the limelight for this, is trying to answer the question, what is AGI? So OpenAI used to have this definition, and I think this was kind of the, we'll call it the feels definition that a lot of people had, is that this is just something that is roughly as smart as humans, as capable as humans in most intellectual tasks. But this seems to be kind of what I would say the common man type researcher would take. Somebody who's maybe not an expert, but just says, this feels like interacting with a human. Recently, OpenAI has changed this for, we're presuming, funding reasons, that AGI is any system that can make $100 billion, which I don't know many companies that can make $100 billion. And I mean,
Like, is that now an official sort of definition that they came up with?
that is the official definition that they came up with, which is quite interesting. I mean, it's definitely so. OpenAI's contract with Microsoft basically says once they reach AGI, Microsoft has no claim to anything that they produce from that point on. And so, obviously, to encourage more funding, more support, they want a more restrictive definition, even if that pushes the timeline down the road for a while. But I don't know about you. I don't have high confidence in myself making $100 billion anytime soon. Who knows? You know, but I don't think that makes me any less human or any less capable as a quote unquote average human. So I think there's a lot of word mincing with this definition. I mean, one of the things that Leopold points out in this, I guess we can call it an op-ed in his trauma dump, maybe we'll call it, from OpenAI, is the fact that if you had shown the state of the art technology that we have now to anybody, even 4 to 6 years ago, they would have said, "This is it, right? We are there. This is as capable as humans on many, many benchmarks. Maybe it can't interact with the world in the same way humans can, but talking to it, there's zero differentiation, right? It passes the Turing test. I think we had papers showing that we were passing the Turing test sporadically 2 to 3 years ago. But also this really intellectual thought work, I guess we can call it, where you see these systems solving problems at the forefront of, maybe I wouldn't call it state of the art research, but for many kind of intermediary tier research problems, even if these systems aren't able to solve it, you're able to get a good way along, especially in a human AI co-design. You can really accelerate work. And I think for a lot of people, maybe we've reached this feels like AGI moment. But so I think in a long answer to the short question, what is the AGI? We don't really know. I really like Dario Amade's take. He's the CEO of Anthropic, and he wrote a piece probably 2 3 months ago about what is AGI, and he said I really don't like the word, and I very much agree with him. And so he says it's something along the lines of a super capable system. So Dario Amade has this take that we're going to have systems that they might not seem human. They might not be able to interact with us. But right, this is an entirely different type of system than this electrical meat that we have inside our heads. And so of course we'd expect it to be a little bit different. But he says it'll do incredible things. And I think that's really what we have to see is at what point do these systems start being able to do things that we as humans might not be able to do?
Yeah, I
I
think
think yeah.
that part is sort of like brings home. I mean, we kind of like gonna go back to sort of like the intro here, but I think that's kind of like illustrates what you just touched on, right? Where's the and that's not even it's like the cutoff is like 23, where if you look at human performance versus the different benchmarks, then we're at some point he says here we're running out of benchmarks, and I guess I don't know if that was before or after scale AI, and now the benchmarking industry has grown quite a bit in the last 2 years, but I think yeah, like the main argument here is you can argue what AGI is, but given the different kind of taste or like if we sort of like zoom out and we get an agreement, then Whether this is coming up on 2027 or 2029, that's not really, that doesn't, I mean, it's weird to say that doesn't matter, but like, that's not
No,
really
you're
the
absolutely right. Like regardless of whether it's 2 years, 3 years, 4 years from now, that's kind of the rounding error. Even on the timeline of AI research, let alone human history or technological development, a couple years here or there. I think I think Ray Kurzweil back in the 90s, in his infamous list of predictions, Ray Kurzweil is this futurist who works at Google. He said 2029 was the year that we would have kind of this superhuman AI that
really
feels different. Yeah. So this was 30 years ago. And I tend to agree kind of with that timeline.
interesting.
We saw, I think it was a year or two ago, an organization that is headed by Francois Chalet, who created, and I know I'm butchering that name. He created the Keras framework. They released this ARC AGI benchmark, and for months people were saying, okay, when AI passes this, that's when we will be kind of in this era of AGI. Um, and then December came, and O3 was announced, OpenAI's kind of flagship reasoning model, and they passed ARC AGI. And then everybody said, "Oh, whoa, 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 whoa! We didn't actually mean that when they passed that we've reached AGI. It just means that we're another step along in that process." And so now one of the leading benchmarks is humanity's last exam, which is really a great name. And so these frontier systems now are achieving kind of in this 20, almost 30% range on humanity's last exam. And who knows, a year from now what the score will be there. But I think really the crux of it is what feels different. Like when do we look out into the world and we feel a substantial change? And I do think that that'll probably be around the end of the decade. Perhaps leading to the next a little bit. But definitely in that 2027 to 2031 range. We're
Yeah,
gonna see
I,
really
I
a
think
really paradigm shift.
this has become pretty much a consensus. I think the it starts with this bold statement, right, when he says, and that was like, I think he worked on this during like the first half of 24 and published on the second half, and he says it's strikingly possible by 2027 models will do the work of an AI researcher engineer, which some people argue this is basically like we're there in 6 months, we're there, which, like, when you say do the work of an AI researcher, that might do the work of it includes maybe things that the model is not capable of
Mhm.
without really a human setting up prompts and reiterating and trying some things more than once. But that's definitely like an interesting and reasonable claim here. And so this is the projection that he makes. And if we look at, I guess a lot of what the article says is, look what happened between ChatGPT 2 to ChatGPT 4, where we moved from like a preschooler to smart high schooler, like level of intelligence or level of reasoning, and then extrapolate. He goes through 3 points in terms of why it would make sense to extrapolate, which let's talk through, because I don't know if I'm as convinced.
So
Yeah,
I want to qualify. I think Leopold is extraordinarily insightful. And obviously his experience at OpenAI gave rise to so many of these incredible thoughts and projections of the future. But I do think, having worked kind of on the other side of like in basically companies that are not the number one institution in the world for this, I think there are limitations that are overlooked here. And we can talk about that as we get to these orders of magnitude. Yeah, I to put it concisely before we get into it, like I've had many meetings with folks who work at the very high end of things like this, both in academia and in the government research labs. And one of the main things is lack of energy. We we don't have enough electricity for many of these projections. Now, if maybe Leopold is claiming that we're gonna overcome the fusion barrier in the next few years, then maybe that's a different story. But Right now, we need to turn the lights on, and at the end of the day, we don't know if that's necessarily possible.
Okay. Very, very interesting. I don't know. Let's see. I don't know because he's making 3 points. I don't know if this is necessarily one of them, right? So he says order of magnitudes. That's the sort of like way to measure the leapfrogs the models are expected to make, which it feels a little bit fuzzy. Maybe it's well defined somewhere, but I've not seen like a very strict definition here. But basically, he said we're gonna have leapfrog order of magnitude jumps in compute, algorithmic efficiency, and this thing he calls unhobbling, right? Unhobbling gains, fixing obvious ways in which models are hobbled by default, unlocking latent capabilities and giving them tools leading to step changes in usefulness. Before we start breaking these down, what's your definition of this unhobbling, which seems like it's a term he coined that I've seen more people are using?
Yeah, so I'm not sure if he coined it, but this is somewhat of a it's just a way to describe the fact that we are using AI in a very human way. Right now, we are trying to effectively make something that is superhuman, but limiting it to human interface, which is right. It's definitely a limitation. So just think, for example, when we talk about human language, right? 6,000 languages in the world, and they all have different encoding schemes. They all have different information densities, syllabic pace. So, how quickly do you speak? How much information does each syllable carry? And we can think of that very similarly then to AI in that we have language because language is a medium for all of us to understand the same thing. For AI, why should this system that is innately inhuman be constrained to these values? So there is obviously some up until this point that the main reason is just that these are chatbots, and I think Leopold points that out here. But now, especially with like the advent of this reinforcement learning paradigm that we see with DeepSeek and in the DeepSeek R1 release a couple weeks ago, we see reinforcement learning being a really, really powerful tool here where effectively the model can learn from scratch. And that is not something that we saw before at very, very large scales. And that is something where we could very much see new types of information encoding really come to be. So rather than just encoding English or any other language on a character basis or on a syllable basis, and feeding that, this is the tokenization scheme that you might hear people talk about, and feeding that into these AI systems, allowing through this unsupervised reinforcement learning process, new information encoding schemes to come about. I think that's where we will see really, really strong shifts. Additionally, like this things like one of the projects we're working on now is OpenAI has in ChatGPT this code interpreter, right? So when ChatGPT isn't sure about something, or maybe it thinks that it can um, write Python code that will allow it to answer a question quicker or more efficiently, it's able to spin up a little shell, write a script,
Yeah.
execute code, and it'll give you the answer. Those are running on very, very small virtual machines, something like 4 cores, 20 gigabytes of RAM, sitting up in the cloud somewhere that they just spin up and crash all the time. So our thought was, what if we did this with supercomputers, right? And so if you give ChatGPT or a more lower level API access variant the ability to use code interpreter on a supercomputer, where now it has several, several orders of magnitude, maybe a million times more compute, that it can actually run full molecular simulations, right? So if we're asking ChatGPT, hey, what's a molecule that might be able to cure COVID? Random example. I don't think it can actually do this. But rather than just guessing, right, it can spin up an entire molecular dynamics simulation that would take hundreds or thousands of years in this little VM that you gave it, and now can take just a couple of seconds on a supercomputer. Um, I think, yeah, just to finish that off, I think really the important aspect of all of that is effectively giving these LLMs the tools that they are able to use rather than using them in a way with our tools. So, like you mentioned earlier, building agentic frameworks around them is really the key here to unhobbling. So basically, allowing them out of the sandbox, as it were, and giving them ways to do that.
Okay, very interesting. So basically 3 unlocks, right? And I guess he like walks us through why he thinks those 3 unlocks are about to happen or on the right track. So we talked about comparison between GPT-2 and 4 and how this should extrapolate, right? So we already know this is like in the vision is great, and we know that the model came after GPT-4 are way smarter than a smart high schooler, right? Like this could be like you would say the O models, the reasoning models are like, I don't know, maybe they're as good as a PhD researcher, maybe not, but definitely better than a high schooler. So we keep on, right? We keep on getting better. What I found particularly interesting, and maybe this is sort of like prove us wrong when we just talked about when this like AGI like is relevant, is he shows here, right here, the like the expectations on some benchmark, like the math data set here, that the researchers had, the forecast versus the actual performance. And so obviously all the forecasters were way off, right? Basically saying it is hard for us because maybe because the human brain is not really exponential, like exponential thinking is not something we're good at. It's hard for us to extrapolate to understand what's coming or in what pace, which I found quite interesting here. So, okay, looking at advancements in orders of magnitude, Sora is an example, probably a good one. And then he goes into compute. Now, this is where you can definitely spill the beans. Many people say, that there's a ceiling. We're not going to move as fast as we possibly can. And maybe, depends who you ask, but maybe now the DeepSeek has proven differently. And so are we heading a compute ceiling, or are we going to keep getting the flops better and better, sort of like a Moore's law, but accelerated?
Yeah, so this is more my specialty. So a lot of what I do is around system sizing. So, like how consultants do a lot with market sizing, saying, what kind of scale of manufacturing do we need? I work on figuring out kind of what scale of compute do we need. This, I think saying that we're going to hit a ceiling is not entirely accurate. I am a huge believer, perhaps incorrectly so, in the chinchilla scaling laws, that we see this logarithmic growth. This chinchilla paper came out back in 2023 and kind of established roughly how much performance gain we get for each order of magnitude increase. And they show that across a wide range of problems, you really do see this kind of logarithmic growth. So with a logarithmic curve, you never hit a ceiling. But for every order of magnitude in compute resources that you move up, you do see substantial marginal decreases or substantial decreases in marginal performance. So you can't say I'm going to put 10 times the amount of compute towards it and it'll be twice as good like the previous generation. You might say I'll put 10 times more and it'll only be 50% as good. And then the next time you add 10 times the amount of compute, it'll be 25% as good.
Yes, I like exponential decrease of, right.
Exactly. But I don't ever see that hitting a wall. One thing that is brought up, and we touched on that a little bit earlier, is this idea of running out of data. I do also think that we've shown very recently, especially like with the DeepSeek case, and rumor has it that the new GPT 4.5 is trained on a substantial quantity of synthetic data. That synthetic data can help make up for where we might have shortages in real human created data.
So let's break this down. Basically, so to wrap up so far, to continue to make this amazing progress, the chips aren't the the showstopper.
Well, chips are always a showstopper, right? If we had an infinitely good chip, we wouldn't need to worry about any of this.
Right. But I mean, given like in this arms race of buying GPUs and TPUs,
Sure.
if there's like, what's the one parameter that's the top of the list in terms of the roadblocks? Is that data?
I think I still maintain that it is compute.
It is compute.
I believe it is compute. I think there's definitely a balance between compute and data, but I also think that it's pretty reasonable to say that without an increase in compute, if we just rapidly increase the amount of data that we have, it's not going to get us very far. Because right now,
No gains. Like basically, there's not going to be that many gains
so I think
given.
I think there are gains. I mean, algorithmic efficiencies here. This is this one area of research that I know is very, very popular. I was just in a job talk about this, where they're finding you can get massive gains by using data more intentionally at different parts in the training process, right? So when you're training one of these large language models, the information that is seen at the beginning of training is going to have a very different effect than, excuse me, than the information if it's seen at a later part in training. And that's just because when you think about how this LLM, we can use the term brain, is shifting through kind of this knowledge space and is shrinking, twisting, banding, contracting to fit these assumptions around language that it's seen previously. Now all of a sudden, if you see, let's use an example that everybody knows, E equals MC squared. Um, as the very, very first thing you see without any previous information, you can memorize that fact. You can say, okay, E equals MC squared. I know that fact. But you don't have any of that preconditioned knowledge on what is E, what is M. Like you don't know what mass is if you're a baby. Like
Yeah.
if you told a 2-year-old, say E equals MC squared, they could probably do it. But they're gonna have no idea what that means. And so then if you gave a physics PhD student E equals MC squared, they could explain for hours all of the implicit assumptions, implications that go into that one little simple equation. And it's the same thing with training. So by intentionally using different types of data at different parts of training, we can see mass uplifts in performance. And so that's like one really strong example of current research that's going on in this algorithmic efficiency that helps us get past the data wall and doesn't really require that much more compute.
So basically, the order that the training data is ordered significantly could impact the rate of training.
Yep. Yep. Exactly.
Is that
And
is that
just
something? Is that something
eventuality.
you think? Yeah, in the performance eventually. And is that something? Is that like an area of research the LLM companies are exploring?
So I don't know about the large LLM companies. I know that some of them do have folks who have looked into this before and that they are using it to a certain extent. Um, but organizations like DeepSeek are going to be the ones who are using this much, much more. I know that this research actually came out of an area of distributed machine learning called federated learning. And that's one of my original areas in machine learning research was in federated learning. And one of our collaborators actually had really great success with this, showing that they could achieve the same performance in kind of this distributed machine learning regime as just throwing all the data together and doing kind of traditional centralized machine learning just by intelligently using the data in all of these different places. So you can overcome a lot of these data barriers just by doing this intelligent selection. And I think more and more folks in the LLM community now are kind of picking up on this fact that not every training step is created equal. And right, we've seen this before with these more complicated learning rate schedules. So, a lot of these labs have started experimenting with how to properly vary learning rates to simulate annealing in a learning process to help the
Mm.
model critical junctures kind of jump out of local minima. And so now we're just seeing the same thing but proxied through data, which I think is really interesting, right? Because you don't learn. I mean, you learn based on the learning rate, but that's just the the size of the vector, if you will, the magnitude. That's the word I was looking for. But with the data, you actually control both the magnitude and the kind of the direction or dimensionality of the vector.
So that's we're covering so much ground. Let's see where it gets us, right? So basically, we say we started by saying, yeah, no good definition for AGI.
Mhm.
Given a fuzzy definition, yeah, likely within the next 5 years. But Leopold makes the argument that going by the definition of replacing AI engineer, this is likely by 2027, which seems reasonable. Looking at the three pillars of how or what could be a showstopper, whether this is um, compute, algorithmic efficiency, data, or this like hubbling, unhubbling situation, we break data down into like now we understand actually data is not just the amount, the sheer amount, but rather also how we order the data and like the the, the order in which we introduce specific data to the like during the training phase, right? The
Yep.
pre, I guess we're talking mostly about pre-training,
Yep.
right?
Talking about pre-training.
Okay, which is super interesting. And so that gets us to basically seeing how to make this argument how each one of those layers leads to figuring out what's the bottleneck, which we haven't really. I mean, you said it might be compute, but it seems like
Well,
the other areas are, obviously not solved, but like solvable, right? Like
so
potentially.
I think the thing that's awesome about compute is it's predictable, right? If we said you have all this data, you have the same algorithms, and now you have 10 times more compute than you did before, I can give you a pretty solid ballpark estimate on what kind of performance you're going to get. And we can extrapolate that up and up. I mean, that was one of the critical things in the GPT-4 paper that OpenAI outlined was I think GPT-4 was really the last time that OpenAI was massively compute constrained. And now, Sam Altman said this last week that they've run out of GPUs, which is maybe true, maybe not true. But I think the interesting thing about that GPT-4 paper is they made this assertion that they could only train it once. They had no time to redo training. They had no compute capacity to leverage multiple training runs and interleave them simultaneously. They had one shot, and they were able to effectively predict exactly the performance that they got out of that one shot training effort. Um, and so that really is the beauty of compute is what you're going to get given the price, which is what makes things like, Project Stargate very interesting, or all of these companies now that are building out 200, 300,000 GPU clusters is we can, assuming no massive algorithmic improvements, we can pretty solidly guesstimate what power of AI model they'll be able to create on different timescales, right? So like I can tell you with pretty high certainty, like what will the performance of Grok 4 be? Because I mean, Elon, for better or worse, is very, very open about the compute that they have. And we can kind of extrapolate saying, okay, we know that Grok 4 is probably going to come out sometime midsummer. So that means that they have about 4 to 6 months on this hardware of approximately 250 to 300,000 GPUs. And we can give rough approximations of what we think that will be. And it
Yeah.
should be pretty good. But I do want to go back to that unhobbling aspect
Yeah.
because this is something that folks talk about a lot, especially with like the O3 launch back in December, was it's basically maxed all of these benchmarks that we have. And you mentioned that we're running out of benchmarks. So there are two sides of this coin, right? There's the hypothesis that if this model had unlimited modes of access to the real world, right? So if it was embodied, if it had unlimited tool use, right? That it could do all these same things as a researcher, because it outperforms them on all of these different benchmarks. And I think folks have shown this to a certain extent, that with proper guide rails, proper frameworks, proper, what's the word I'm using? They use some term that basically said that if we wrap up the model and package it in such a way for this one specific problem, it gets superhuman performance. And I think that is indicative to say that if we were to figure out kind of this moonshot of unhobbling, the current models we have might be able to reach this kind of very fuzzy AGI level.
Yeah. Okay. So,
Yeah.
like, if I'm putting what you're saying in layman's terms, then if we were to learn to speak to the models the way they better understand and not human language, we would be able to unlock much greater potential than what we already see today.
Yeah, and I don't think it's even human versus non-human language. That's definitely one unhobbling technique. But I think the models that we have right now are all very grounded in human language, usually English. And it's really just how do they interact with the outside world? And I think if we have that Transformers moment for tying current LLMs together with things like tool use, system control, even just something like alignment and priority setting, that's where we're going to see really, really interesting developments in that unhobbling space. Because, there are folks that have basically said the hypothesis is if you as a human can guide the model to do superhuman things, that with the proper crutch, the proper framework, proper wrapper, it should be able to do it on its own, which
Already today.
already today, which is an
Yeah.
interesting hypothesis. And I don't know if I fully ascribe to that, but I think the alternative hypothesis is just to say, we are going to take these really, really restrictive tools that we currently give these models, and we're just going to make the model so smart that it's able to use these really terrible things that we've given it. And basically, right, if you had somebody really, really, really smart, they could build a 10-story building with a rock and a stick, you know.
Yeah. Yeah.
But if you have maybe not so smart people, they need AutoCAD. And so you kind of have this differentiation here.
Interesting. I like the analogy. It drives the point home. So on this let's see what Leopold says on this unhobbling thing. The hardest to quantify, no less important category of improvements, what I call unhobbling. Ask yourself a hard math problem. You had to instantly answer with the very first thing that come to mind. It's obvious that you would have hard time. That's how we had LMs solve math problems. Instead, most of us worked through problems step by step, and that really basically explaining what chain of thought is, right? Which is sort of like has come to be almost a standard for many people at this point. Despite excellent strong capabilities, they were much worse at math than they could be because they were hobbled in an obvious way, and it took a small algorithmic tweak to unlock much greater capabilities. That's basically what you just said. And then it touches on a couple of interesting points. So we can quickly go through them. One, the RLHF. So base models have incredible latent capabilities, but they're raw and incredibly hard to work with. So just for the sake of the audience, you want to quickly explain what he means here and what are base models?
Yeah, so these base models are what you get after pre-training, effectively. So this is just auto-regressive token in, token out, not really set up in the ChatGPT way. This is more like super, super smart autocomplete.
Yeah, it just like predicts the next word, but doesn't really. It's not a chat interface.
Exactly.
And
Yep.
then
It's not, it
for
won't
anyone,
take instructions. It won't do any of that. It's just, you would basically put in the first 4 sentences of an essay and it would finish the essay. And I think that the point that Leopold here makes is really, really interesting, because if you look at, there's a great website that I surf way too often. It's called the Open LLM Leaderboard, that basically shows how all of these open models like Llama all compare to each other. And you can see this really stark contrast that there are tasks on this leaderboard, that this leaderboard measures, that these base pre-trained models do really, really well on. But then the second that they're instruction fine-tuned. So basically turn from these raw autocomplete models into chatbots. Now, other benchmarks get way better, like instruction following, but things like pure intelligence, like GPQA, this Google proof question and answering, get way worse.
Really?
Yeah, and so it's really a fascinating thing, and I think here maybe um, I know some of the areas that have worked on this do things where, like, if you have one of these instruction fine-tuned models, you can then use those to invoke these pre-trained models on certain inputs. One interesting example of this from the early days, being 2 years ago, was made by Hugging Face itself, called Hugging GPT, where basically the idea was using GPT-4 to invoke all of the models from Hugging Face's repositories on specific input. And so that to me was incredibly interesting because now it's AI effectively using AI, right? You know, we all use ChatGPT in our jobs. And so now ChatGPT is using AI to complement its own skills. So I think we're going to get to a point where obviously that's again many orders of magnitude larger, but kind of has the same pattern of uh, any generalist agent is going to use these sort of specialty actors in order to do more more thoughtful, more directed application specific work.
So here, okay, so here the reinforcement learning with human feedback, right? RLHF. Like how would that so basically for anyone who's not familiar, this is like really big LLM companies. They have, I guess, pretty big teams, um, doing both providing human feedback and also taking a big part in the post training, providing like writing answers to questions to post train models. But that's another thing in terms of the human feedback as part of reinforcement learning. How was that? Like, how would that factor into this unhobbling thing, or is that really the unlock?
So this reinforcement learning with human feedback, you have generally this is done in a couple of ways. One of the main ones is really the system outputs two two potential answers, and a human just says this one is better or this one is better.
Yeah, we've
There
all
are
seen this
also
in
more.
OpenAI.
Sorry.
We've all experienced this as part of the UX in ChatGPT.
Exactly. I mean, it's right. It's A/B testing, but there's also more complicated versions where users are basically responsible, who are subject matter experts, to provide interesting questions and then guide answers. So, like, this is something we've done with our internal LLM efforts at Argonne, is basically getting together a bunch of academics and saying, take this list of 1,000 academic papers and come up with interesting questions that you can answer using these papers, but things that aren't immediately obvious. And then you can do reinforcement learning on that with the LLM. So you have varying levels of this. If you look on like all the big LLM websites, they have job postings. Like I think Ex-AI has the best title. It's like you are an AI math tutor.
Sure.
Where basically you just have to have a math specialty, and your whole thing is teaching the AI how to better do math. So I think, yeah, RLHF is something that is very useful. I don't know the unhobblingness. Like they say, this is what led to the Chat GPT moment. But going forward, I think that's going to be the most difficult thing, right? Because humans scale terribly. Compute scales
Yeah.
really well. Humans are terrible.
Uh, yeah. Okay. That's an interesting direction. And yeah, there's well, basically he's listing here chain of thought scaffolding, which is like well, like an extreme chain of thought kind of way to think about it. Right? Tools. So that's starts sounding like agents, where agents use tools, right?
Yep.
Very
Yeah.
much. I guess it's just a terminology kind of thing. And then context that since publishing this has grown quite dramatically, right? We're talking about like north 2 million tokens as like a context window.
Yeah. The interesting thing about context length is, and this is highly contested in the AI research space, is obviously more is better, right? Like nobody's going to deny that. But it's the type of thing that, right, if you think about how the human mind works, and it's always a terrible analogy to say, like, these LLMs are like the human mind. But think about, like, what we can fit in our short term memory, right? Like, I would be hard pressed to remember the exact, like, word for word sentence that you said 30 seconds ago.
Yeah.
I can pull out little pieces. I know roughly what you said, but if you asked me to repeat word for word what you said, 30 seconds, a minute ago, I probably couldn't do it. And so in this case, the way that these transformer models work is we have this long context window that basically allows you to do a pairwise comparison across every single token for that entire context length. So it scales terribly, but it's also, it's not it's not something that we see as evidentiarily necessary to having greater thought. Um, so there are some really interesting works recently. One that came out of, I believe it was DeepMind, and one out of Sakana AI that basically promoted this idea of memory enhanced transformers. So transformers that are able to have a stronger latent space or to do in context learning and effectively not rely on the context length growing exponentially, or I should say quadratically. And so with this, you're effectively able to compress parts of the context. And I think several other LLM labs do this as well. I know I'm pretty sure Cursor does this, the AI powered VS Code company,
Yeah. Hmm.
where they basically use LLMs to summarize past parts of the context, and then they just feed that into the next LLM. So I
Which
think,
is, which is like pretty much. I mean, I know this it triggers some people, but like that's pretty much a agentic workflow, right? Like, there's no reason to not call it an agent.
yeah, yeah. I mean, agent. I don't know. I think that's an overloaded term,
Yeah.
but yeah, I think it could be, but it could also be built in to the transformer architecture itself, right? If there was, let's say, within every transformer block, there's just a latent memory block, right? That is effectively taking a million tokens and compressing it down to a, small 1,000 dimensional vector. Like that is something that is well within the realm of possibility. Like we saw this in LSTMs, and of course, LSTMs also don't scale very well, but it's something that can be done and is at an um, a very strong inflection point right now that where research is being done on it and that there are interesting directions to go very, very soon.
Definitely interesting. Let's see what he got us as a projection, which we are exactly. I find it fascinating because we're really midway his projection, right? Which I guess it seems like he knew what he was talking about, and so he was saying between 23 and 27, you would have 2 to 3 order of magnitudes in compute. Um, so that's like basically would be like, I guess when you say 2 to 3, that's like 50 times better, right? Like if you go for, or actually,
No, 500 times.
yeah, it's like, oh
Yeah.
yeah, it's like I should never do public math. That should be my
Yeah.
number one
No,
rule.
that's the first failing. See,
But
AI isn't good at
we should
math.
expect, yeah, yeah, but we should expect to have like 500 um, times better compute in 27 than we had in 23, which I don't know. We are if we're on that track. Um, I guess what happened between 23 and 25? Well, you would know much better than me.
So if we look, and I can pull up the sheet where we kind of keep track of things like this. If we look at kind of the speed ups that we've had on just the fastest system, right? And so there's a difference here between just what compute system are we using and what is actually being used for training. We
Mhm.
have the fastest systems speeding up by maybe about 10, maybe a little more than 10, 10 times. So that's one to 1.5 orders of magnitude. But you see
Mhm.
so much more of this used for actual training, right? So we know about what it took to train GPT-4, and there are rumors. I want to emphasize very much rumors about what it took to train GPT And we can say with a reasonable level of confidence that it was definitely much more than an order of magnitude increase. We're thinking it's nearing 2 orders of magnitude, just in terms of time.
Okay, so that one is pretty much like we can say it's almost on track. It's almost
Yeah,
on track,
yeah.
right?
I think saying that it is on track is definitely accurate. Um, I I think the interesting thing is going to be this balance, right? Because there's always a balance of if I use my supercomputer to do a lot of smaller models that can progress very fast, right? Like OpenAI releases a new model roughly every 2 months or so. That's been about the average over the past year, year and a half. What if they used all of their resources on one model for the next 2 years?
Yeah.
That is the question that gets really, really intriguing, right? And I think that is one of the reasons why, like Elon has basically said, we're going to get as much compute as physically possible because rather than hoping for these algorithmic increases, these unhobbling increases, we basically just say, what if we could do 2 years worth of compute in the next 6 months? And that is the answer that they are trying to get. And with the release of Grok 3 is excellent. And so I think we see that there is success. So yeah,
Yeah, which
long story short, Leopold is right that we are definitely seeing these orders of magnitude increases. But
going back here, would you say as here across the field we see compute we discussed, but also algorithmic efficiency and unhobbling?
so algorithmic efficiency definitely. Right? We've seen O1 and O3 being massive successes. O3 is a much smaller model than GPT 4.5, but is able to do way more. I don't think anybody would say that O3 is a quote unquote dumber model than GPT 4.5. It just works differently. And so now really the question becomes, what if we apply all the same principles that were used to build O3 to a model the scale of GPT 4.5?
Mm,
And so
mm.
that's where I think we'll go from kind of that 1 to 2 orders of magnitude algorithmic efficiency to potentially 3.
Is that the next thing coming out of OpenAI?
So we don't know for sure what's next. We know that GPT-5 is going to be kind of this multiple models all wearing a trench coat and a hat that is composed of something that resembles GPT 4.5 and O3. Um, and so how those work together, we've yet to see. Um, but it's probably going to look much more like one of these like agentic swarm of agents sort of thing than just your typical chatbot interface. Just, I mean, to the end user, it's going to still look like a chatbot interface. But when you actually look behind the scenes, it's not going to just be words in and words out, which I think is really, really interesting and allows for definitely greater efficiency because people, again, don't know how to use these resources properly. But I think that will probably be a big release that that really sets the tone for what we do for the next year to two. I think most people are expecting word on what this is going to look like sometime early summer. And when they're going to actually release it, who knows? Obviously, O3 was announced in December, and it won't be released until at least, until GPT-5 comes out. That could be early summer, early fall.
The non-mini O3, right? We should say.
Correct, correct. Yeah, O3 Mini is fantastic. On most things, it's still worse than O1 Pro.
Let's see how he puts basically everything together. He says um, maybe that's how he puts everything together. Um, basically, we're racing through many more order of magnitudes in the next decade than we might in multiple decades thereafter. Okay, that's like half pessimistic. Okay, maybe it's enough. We get to AGI soon. We might in for a long, slow slog. Basically, he says because he makes this argument where he says this decade or a bust.
Mm-hmm.
Can you give us a word on why is that the argument? Like that doesn't really compile. If you think on like who says the returns are becoming marginal at some point.
Yeah, so that is that is really the crux of the matter because, like I said, we know roughly kind of what increases we get from scaling compute. We know sort of how big we can build things, right? Like there's a tweet that went sort of viral from this guy who was working with Microsoft, and they basically said, well, we need to figure out how to do cross data center training because if you put more than 100,000 GPUs in one localized area, you start to shut down the power grid. So we know that there's a cap to how big we can build. And the question is, do we get a transformative technology before we hit that extreme diminishing return? We know that we can build clusters, just highly distributed clusters,
So the diminishing returns because of the grade,
because of what? Sorry?
like because of the grade, because like we cannot like
Yeah,
diminishing
because of the
because
grid,
like,
because of just even heat density, right? Like it's been seen around these data centers that like there is a measurable change to the local microclimate just because you have to get rid of all of this heat that you put in, which is insane. There's really, really cool work being done by a couple of research labs and by a couple of companies about like reclaiming this heat into power, like thermoelectric generators, which I think that would be incredible. Like that would be really transformative to the industry, right? Because I think it's something on the order of 90, it's mid to high 90% of the power that we put in just gets turned to heat.
yeah, yeah, by spinning, but like spinning
Exactly.
it.
And so if we can turn that heat back into electricity, even at a 50% rate, right? Like that allows us to double the amount of compute for the same cooling, most importantly, but also for the same power. So things like that are huge. I think there is a huge untapped area behind like chip efficiency. We have this idea of Dennard scaling that basically says as transistors get smaller, you can use the same amount of power to get the same amount of compute, or to get exponentially more compute. And we've really seen the death, even more so than Moore's law, the death of Dennard scaling, right? Like going from, you've heard the terms like 7 nanometer chips or 14 nanometer chips down to now we're at like 2 nanometers. In theory, that should yield us something like a 10 to 100 times efficiency boost, but it doesn't. Just because in order to get all available compute out of these chips, we're pushing so much power through it. And so by regaining some of those efficiencies, which all of these lithography systems, these semiconductor manufacturers are all using AI to do better chip design now, like we're getting there. And so I think that's the heart of what Leopold is talking about here. It's now or never. Because if we exploit all of these resources that we currently have, and we don't get to that point where we have this transformative technology to really accelerate us forward, we're going to be massively slowed down. And I think that's what we see, like going back to our talk about um, the training of GPT-4, how they had one chance to train it. That's just because 4 years ago, there wasn't this emphasis on building the biggest clusters, building these massive power generators right next to data centers, Microsoft buying a nuclear power plant. And so we have this massive, massive growth. I mean, you've seen Jensen Huang give that presentation probably a dozen times of AI training power is increasing by 6x every year. That's only because that's what our priority is now. And so we had all this headroom for the past few decades that if we kind of did a AI, or we can even generalize it to say a compute Manhattan project where we're putting all of our resources towards compute. If we
Mm-hmm.
had done that in the past, the progress over time would be so much slower than we see currently. And that's just because we've built up this overhead over the past few decades, and now we're exploiting all of that overhead in just a couple of years. So if we reach to that point where we have to revert back to the old rate of change, kind of I think it's pretty reasonable to say a Moore's law rate,
Yeah.
1.5 times per year. Think I think there's going to be much less interest because the payoff won't be as quick. because of that, we're going to go back into this regime of not really putting any money into it, coupled with the fact that we've used up all this overhead that we've built up, this technological overhead, that, who knows how long it'll take thereafter, interest starts up again, and we start doing these sort of moonshot projects like Project Stargate in order to reach these levels of truly transformative technology. I mean, in my opinion, once fusion is solved and once fusion is solved and once chip design is solved, then we don't have to worry anymore. Not that things are limitless, but that allows us, right? It's just like the transformation from GPT-4 to O1. It's a whole new paradigm of scaling that we can exploit. So
Yeah.
that's really what I think AI offers the most promise for, is allowing us to access those new paradigms of scaling. And that's what Leopold is talking about, is can we access those before we have to revert back to the old days where we're just growing at 50% a year. And 50% a year is still insanely quickly in the grand scheme of most things that grow. But compared to the 5 to 10x that we've been experiencing over the past few years, it's going to seem like we're moving at a snail's pace.
Yeah. No, that's amazing. That you bringing it home, putting it all together. So I think we covered so much, but it's funny how we went full circle, starting with the grid and electricity and ending up with the same kind of thing after basically going through process of elimination to see what's a bottleneck and realizing maybe the bottlenecks are different than what is a common wisdom. So I was a tiny bit surprised. Amazing. I think we pretty much covered the main argument Leopold is making here,
Mhm.
but the premise and the why and why not this decade or a bust. I think it's very interesting way to think about it.
Definitely.
What's your one-liner take? Give me your one-liner take on this.
My one-liner take, I won't say 6-word stories because I don't trust my ability to count to 6 on a live stream. But I think the one-liner take is we need to invest in moonshots. I think increasingly so, we have skepticism in this area, and I think that is incredibly well warranted. I think 90% of these companies will fail. I think 99% of these projects will fail. But for the couple that will succeed, that it ushers in this new paradigm that we can ride for the next decade or two. And so I think it would be a shame to forego the potential benefits by not investing in these sort of moonshots. I think we have Project Stargate, I think is really the first that we've seen. And now it is debatable kind of how real that is. From what I've heard internally, the 500 billion is not entirely real, but it is definitely on the order of a couple hundred billion. And so that gets us a good way there.
Hmm.
I think probably it's going to be clear in the next 1 to 2 generations, so in the next 6 months to a year, whether or not we are on the track to success. And I think the only way that we are going to guarantee that we get a positive indication is by pursuing these